Hello everybody, welcome back. This is part 2 of how to store your Wi-Fi credentials on your ESP8266. So let's jump into it. In part 1, we learned how to store your Wi-Fi credentials and passwords onto your ESP8266. In this part 2, we're going to learn how to retrieve that from memory. We're going to also at the end build a completed project where you use a little switch to set your IoT project either in setup mode or in normal operation mode. If you have not seen part 1 yet, there is a link below. Click on part 1 and first watch that, because otherwise part 2 doesn't make any sense to you. Because of the length of this video, as part 1, I will put the section times down in the description of this video, so you don't have to go and find it if you are lost. As I said earlier, it is really important that you do part 1 first, because we're building upon that data that has been stored on the ESP8266. So if you've not watched it, go back. Otherwise, let's start with section 1, how to read some data out of memory. We've reached section 1 of part 2 of the tutorial. Wow, that's a lot of information there. First thing we're going to do is we're going to download this EEPROM read.ino. You can find that in my blog, and the link of my blog is in the description as always. Before we go further, make sure that you actually have done part 1 of the tutorial. At least have run this Wi-Fi access point sketch from part 1, and I put a link in the description for part 1 of the tutorial too, so you can actually get to it. If you have not done part 1 of the tutorial, I would recommend that you do, because everything we do from this point on is basically built upon that you actually stored the data into memory that we're going to read out. Now let's go see how we're going to use the EEPROM to read data. This is basically the meat of the sketch. Like, we declared a variable called string value, and that's basically all we've done, and we've included the library. So in this for loop, what we do is we're going to read one character at a time. We're going to read the SSID, and it starts at position 0 and has 30 characters in it. In this if statement, this is actually the work here. What we do is we read a character out of memory in that end position, and we compare it. If it's not the end of data character, we go into and store that one character into the string value. But you see, it's a little bit more complex. So to read this information out of memory, we need to first create it as a character, as an ASCII character, and then after we've created it, an ASCII character out of it, to stick it in a string, we need to basically convert it back to a string, and we do that with the string brackets, and then we store it in the string value over here. So we go through it until we actually reach this control character, and we jump out of the loop, and it prints your SSID value that you've stored into memory. See, straightforward, simple. It becomes a little bit more complex when you actually have to massage the data to actually prepare the data to be used correctly. So let's go to section 2, where we look at how to use that data that's stored in memory and connect to your Wi-Fi router. We read section 2. In this section, we're going to actually read the data you stored in tutorial part 1 section 3 your SSID, password, your IP and your gateway information. We're going to read that out of memory. We're going to use it to connect to the Wi-Fi router and to make it so that you can actually have the onboard LED on and off by typing in commands in your web browser. So let's jump into it and see how it all works. So the first thing that we're going to do is, as usual, we're going to download the sketch. It's always a good idea to have the sketch open that you can follow along, because I don't show all the code all the time. As I said, we're building on the data from this sketch here that you can download in part 1 of the tutorial, and then write in your SSID, password, IP and gateway information. We're going to read out this information and we're going to bind this information to your ESP8266. At the top of the sketch there's 4 variables that I actually want to look at. Is the SSID char and the password char. I don't like chars too much, but you have to use them, especially if you use this command here, which connects your development board to your Wi-Fi router, and it needs 2 char arrays, the SSID and the password. This group here, the IP group, the integer, is to keep track of what group of numbers we're reading in on an IP. An IP address is basically a group of 4 integers separated by periods, and this variable is going to help us organize that. And then the string IP is a fairly straightforward thing. It's a variable we're going to temporarily store the IP information in. So let's go see how that all fits together. So the first thing we're going to do is we're going to read the password out of memory. We declare 2 strings where we're going to temporarily store the data in. We're going to read the information out by the means of this function that we're going to look at in a bit, how that function works. And basically what we do is we tell the function that it's the length and the location. Remember, your SSID is in memory slot 0 in your flash memory, and it's 30 characters long. The same we do with the password, only it starts in memory slot 100. Now this is where we change these strings into an array, and you do that by basically you give the string name, the toArray command, and then you give the array char array name and the length of it, and it actually converts a string into a char array. Fairly simple. That's what we do here. And then we have our arrays for later on when we're going to connect to your Wi-Fi router. Here you see how we read the information out. It's basically the same as section 1 of this part 2 tutorial. You see it's really fairly straightforward. We read the information out through a for loop, and then when we have finished reading it through, we return it to basically be stored into one of these strings. The IP is a little bit more complex. It's one string that we store that is separated with periods and with semicolons for the end of data string. So here you basically have an if statement. The if statement basically checks if we encountered either a period or a control character. If we have not encountered that, what we do is we just append to that character that we read out of memory to this string IP variable. If we encounter either a period or a semicolon, what we do is we take that string that we have appended to and we send it to the IP convert function. And the IP convert function basically converts a string into an integer. And then we store this into this variable here, which is an array, an integer array, where we can store 5 groups of integers in. And that is really nice because the IP address has 4 and the gateway has 5. And then we keep track of which numbers we are reading in with this IP group. And it keeps it nice and steady in one little package and easy to work with in a little bit. The only difference between this here if statement and this if statement, that this if statement is designed to jump out of the loop if we actually find this. So with making n 217 is greater than 216, we jump out of the loop and we have read in our IP information. Next, what we're doing is looking at how to convert that string into an integer. And we do that within this little subroutine here. And you see it's fairly simple. What we do is we get a string, we call it convert, and we're going to convert it into an integer. And you convert a string to an integer with this here. If the string can't be converted, the function returns a value of not true. So with this if statement, what we do, if the function returns a value of not true, the if statement fails and we go to the else where we return a value of 400. So that means is the string contains characters that we can't convert to an integer, and therefore it's an error. And you could use that for error checking. If the string can be converted to a number, we do so, and then we reset the global variable string IP so that we can start adding new data to it, and we return the integer that we have created over here and get stored into this variable. Now we've read the data out of memory, it's time to actually connect it to your wireless router. What we do first is we create an IP address. An IP address is what I said is a group of 4, 1, 2, 3, 4 integers. We've stored that in the IP info, so 0 is the first group, 1 is the second group, 2 is the third group, and 3 is the fourth group. And we make an IP address out of it. We do the same with the gateway. You see that we first use the first 3 groups from the IP address, and then we use the gateway address as the last one. We add the subnet, and now it's ready to configure your IP information. You do that with this here, where you basically say the IP, gateway, and subnet, and then you now have an IP stack configured. The next thing is we're going to connect to our Wi-Fi router, and we do that with this here. This basically starts the connection process. It doesn't go like instantly. Mostly it takes like a couple of seconds. So right behind this here on line 97, we have on line 99 a while loop. And what this while loop does, it basically says as long as we are not connected, go through this loop. And what it does, it blinks the onboard LED of your ESP8266, huzzah, and it blinks it until it connects. And it takes about between 3 and 10 seconds, sometimes 15 seconds. So as long as that light is blinking, it basically means that it's not connected. This Wi-Fi status gives a number. And you can, if it doesn't connect, you can actually look up this number, what it means. Most of the time it has to do with that your password or your SSID is incorrect. It does not check if the IP address is correct. The IP address has nothing to do with the connection. If the IP address is incorrect, you still can't connect to your device. And even though it's connected to your Wi-Fi router, if the IP address is not part of your subnet, then it won't be able to be found. And there is no amount of error checking that can actually deal with that. This is the end of section 2. Compile the sketch and go to the root of the IP you defined. It will give you instructions on what to do, on how you can turn the LED, onboard LED, on and off. Let's go to section 3. We've reached section 3, where we're actually going to take the sketch from section 3 part 1 of the tutorial and the sketch from section 2 part 2 of the tutorial and put them in one sketch. And there will be some issues, and that's what we're going to be dealing with. So let's look at it. So first, download the sketch. That's where I always start. So we have added a little on and off switch to put it in setup mode or into normal mode. We have to look at that. We have to look at some of the changes in code that we've done. We also changed how we create the form to facilitate error checking. And we have added error checking. So let's go and jump into it. So here's the form. The hardware. Here's that switch. It is a toggle switch, an on and off switch. That's this ST stands for single pole, single state. So it can either be on or off. So if the switch is on, we are in setup mode. If the switch is off, we're in normal mode. So we're checking this from port 13. And here is the pull-up resistor that is required for this kind of operation. And there you go. Fairly straightforward, easy to do. Now, let's go look at some of the code. So the first thing we're looking at is the major changes. As I said, we've got 2 sketches and we put them in one. Just to make it more readable and to separate the code, because if you look at the other sketches, most of the code is in the setup function of your sketch. We have created 2 functions. The IoT function is for the Internet of Things device, and the wireless access point function is for the setup part of the sketch. You notice that if the switch is on, it's really weird, it gives the value of low. We are in the wireless access point function, and otherwise in the IoT function. And I have pulled out the code that they had in common, and I was made basically this web server part here. Oh, my scanner is not working. Well, that's okay. And we basically are ready to go and look at some of the more impactful changes that we've made. This is sort of more like organizational changes. is what I said. So the way that we make the web form has changed. So what happens is we have a function that creates the form now, and you can give it variables, the SSID, the password, the IP, and the gateway. Those are there for when you press submit and it goes through error checking and finds an error, that it gives you your input values back, so that you don't start with an empty form again, because that is really frustrating. So when somebody presses the send button after typing in all the information, the submit, it goes to the submit handle here, and it goes to the handle submit function. So that's how we deal with it now. So let's go look at the handle submit function. So in the handle submit function, you basically, what we do is, this is the area that is of interest. Most of the other stuff has not changed. We have added some little things, but nothing really important. So we do the error checking here. We have an array that can hold 4 integers for the error checking. You basically have 4 error checkings. We check for the SSID, the password, the IP, and the gateway. If in these error checkings there is an error to be found, it returns 01. Otherwise, it returns a 0. So what we do over here is we go through all of these results, and if one of them isn't is something else than 0, we create the web form, and then we send it off to the browser so that the person actually can see. In the error checking, we actually generate error messages that also will be displayed on the form. So let's look how that's done. So if we look at the password checking, the first thing is we look, is it smaller than 8? Because that's the minimal amount of characters that most passwords require. Or if it's smaller than 8, or if it's greater than 30, because that's the maximum amount of characters that we allowed, then your password can't be smaller than 8 and bigger than 30. That error message is sent. You see, it sends the error number is 1, and we're done. So you see this pass argument. This variable is a global variable. They're here. So for the SSID there is 1, for the password there is 1, for the IP is 1, and the gateway is 1. So what that does, it basically gives these fields a value, and when the form is displayed, it will also display these variables. So if they have a content, they will automatically display in the form. Now, in the password checking, we do something, we do string analysis, because we are looking for a little bit more. Like, for instance, in the in the IP part, the IP error checking here, we check if the string that we receive contains something that isn't a number. So we say if it is alpha, which is alpha stands for letters. If it has a letter in it, it is not right. And then we create this error message. See this number here? This number is more for you as technical support. So if somebody says, I got this error message, then you ask them to take, and then you can see where the error message comes from. So it returns a 1, and then it goes into the other functions. I put a link in
the blog that actually shows you all the capabilities of checking, analyzing strings for problems. And this is basically one of them.
If you enjoyed this tutorial and you would like to see more of this, please subscribe to my channel and check the little bell to get notifications when I post new ones. You can also like my Facebook page or subscribe to my newsletter and get a monthly newsletter on what's happening in the Arduino world. Have a great day, hope to see you soon, bye for now.